In this video, we're going to concentrate on the product rule. Now, one thing I should have mentioned at the start of the last video, all of the rules to do with differentiation can be found on page 25 of our log tables book. So you don't actually have to remember any of these formulas. All of them exist on page 25 and you'll have that with you in your exam. So for the product rule, so in the previous video we looked at our basic rule for dealing with a normal function where we have a sum of different terms in a function. For example, a quadratic function might be 2x squared plus 4x plus 5, and we looked at differentiating that. For the product rule, we have to be able to deal with maybe functions that are multiplied together. Now, in certain circumstances, we have a choice of multiplying out the function first and then differentiating, or we can simply use this product rule. So for example, something that we may look at using the product rule for is if we have, say for example, y is equal to 2x minus 1 by x squared plus 4. All right, so here we have a product of two functions. Product means multiplying. Now, in this scenario, we have a choice. We can either multiply out the brackets using our array method and then differentiate as a second step, or we can use our product rule from the get-go. So we're going to look at both options. We'll see that we do get the exact same answer, but in certain circumstances, we will have to be able to use the product rule, and that's why we need to be able to go through it. So the product rule states that where y is equal to u multiplied by v, the derivative dy dx is equal to u times by dv dx plus v times by du dx. Again, that rule is on page 25 of our log table, so we don't have to learn that off, okay? So the first thing we need to do when we come across a function like this is to separate it into its parts. So we have y is equal to u times by v, where u is equal to the first part of our function, our first bracket here, which is 2x minus 1, and v is equal to the second bracket, which is x squared plus 4. So we separate the function first. The next step is to differentiate our sections separately. Now remember, the derivative, the dy dx, means the rate of change of y with respect to x. If we look at this, what we have here, we don't have a y, so we can't find dy dx of this function. We have u is equal to 2x minus 1. So we find the rate at which u changes with respect to x. So we differentiate u with respect to x. So remember, a linear component, we drop the x, and a constant becomes 0. So du dx in this case becomes 2. We then repeat the process with v. We look at dv dx. X squared, bring down the power and multiply, reduce the power by 1, that becomes 2x. 4 disappears because it's a constant, becomes 0. So now that we have our derivatives, we simply input it into our formula here and multiply out and simplify. So dy dx is going to equal, so the first thing we do is we multiply u by the derivative of v, so u times by dv dx, so that's 2x minus 1 by 2x. We are going to add to that v, which is x squared plus 4, multiplied by du dx, which is 2. So multiplying out here, we have 2x by 2x is 4x squared, minus 1 by 2x is minus 2x. X squared by 2 is 2x squared. And 4 by 2 is 8. Tidying it up, we have 4x squared and 2x squared is 6x squared minus 2x plus 8. So that is our final answer for our derivative. Fully simplified, our answer will be dy dx is equal to 6x squared minus 2x plus 8. Now, if we go back to our original function and take, so that's using the product rule, which is a fully valid way of finding the derivative. Now we also have the option of simply multiplying it out. So I'm going to leave my answer, my final answer here at the end, and we'll see, do we get the exact same answer if we multiply the brackets out first and then differentiate as a second step. So when we're multiplying this out, if we use our array method here, we can multiply there. So 2x by x squared gives me 2x cubed. 2x by 4 is 8x. Minus 1 by x squared is minus x squared. And minus 1 by 4 is minus 4. So we get 2x cubed minus x squared plus 8x, and we have minus 4. So this is y. Remember, we're looking for dy dx. So if we take the first part here, bring down the power and multiply, reduce the power by 1, that becomes 6x squared. Bring down the power and multiply, reduce the power by 1, that becomes 2x. Bring down the power and multiply, reduce the power by 1, that becomes a plus 8, and the minus 4 simply becomes 0. So we do actually get the exact same answer at the end, even though we multiplied out first and then looked at the derivative as a second step. But like I said, there will be certain cases where we won't be able to use this product rule here. So for example, if we have the product of say a normal function and then a trigonometric function. In this case here, we can't multiply out and simplify. So therefore we would have to use the product rule for this. Now I'm going to come across situations like this a little bit later when we start looking at trigonometric functions. But for now, that is how we look at using the product rule. So you take each part separately. So we split the product down into u, first function, and v, second function, differentiate them separately, and then apply them to the rule which is found on page 25 of our log tables.